Welcome to Devon and Cornwall Microsoft Power BI User Group. Today we have Paul Lucassen, who is going to be talking through how to carry out geospatial analysis in Power BI. Before I hand over to Paul, I'd just like to draw your attention to our future speakers. Next week we have Laura GB talking about Power Automate and Power BI, followed by a whole host of speakers, which I think will give you an amazing experience. So I'm going to hand over to Paul. This is Paul. He's been a great fan and supporter of our user group, and also he's been a very nice friend to me as well throughout the time I've been online and using Power BI. So I'm going to hand over to you, Paul, and let you start sharing and take the stage, as they say.
Well, my name is Paul Lucassen, and my working environment has always been in transportation and logistics, hence the mapping. For over 14 years now, I've been working as an independent management and Power BI consultant, and I'm providing analysis and visualization in dashboards and GIS software. As an enterprise DNA expert, I've delivered content for several geospatial analysis courses. They are available on the website and several videos on YouTube as well. My customers are logistics companies and manufacturers seeking dynamic analysis and visualization for things like where are my customers, greenfield and brownfield analysis. I will come back to that later, hopefully in time. And do we need to restructure our hub and spoke distribution network given a changing environment? I've prepared a number of Power BI models. I've got something on the internet, and I've got something in QGIS. I start off with dynamic territories with field parameters. And then I do a few things in well-known text. So I'll just kick off and you can follow along. So the first example is, and before we start, we should obviously ask ourselves a question. When you start mapping, what do you want to map? Today, Microsoft offers 4 map visuals with the shape map in preview. This is the shape map. With the map, the field map, which is this one, and the Azure map. And supposedly they're going to replace all the other ones and keep the Azure map in place. The field map is not really working as expected outside the US, at least in my case. And the Azure map is giving us trouble every now and then when it starts freezing up, and they haven't yet resolved it. Moreover, all these visuals simply lack the capabilities of custom visuals like Icon Map and Mapbox. And I've got examples of both Icon Map and Mapbox in this presentation. So the first question on mapping should obviously be, what do you want to map? And which visual do you want to use? The next question is, are you limited because your clients will not allow custom visuals, which happens? So if you do, you will face restrictions using the standard maps. And is it a simple bubble map displaying in just customers or distribution centers? And how accurate do you want this to be? Most people do not realize, but they show latitude and longitude with 8, 10, 12 decimals. And in fact, if you have 5 decimals, the accuracy is up to 1 meter. And 8 decimals is already 1 millimeter. Now, if you consider that having more decimals in Power BI is actually growing the model and actually adds to the rendering time, what I normally do is simply round to 4 decimals, which is 10 meters, 11 meters, which is by far enough for most of the mapping that we will do in Power BI. So is it just a bubble map, or do you want to aggregate your data geographically by means of areas, such as postcode boundaries, sales territories, municipalities, or even hexagons like Uber uses with H3, which you can use if you want to keep your geography constant? And should they be clickable or dynamic maps, which you can host on GitHub? Or do you want to store the boundaries local in Icon Map as well-known text? You can also add a simple reference layer, which is a static background, and you can play and display boundaries or distance bands on the map, but they are not dynamic. I use QGIS for most of the time, which is free software, to create my shapes and my shape files. And I will show this later on. It's accessible and it's relatively easy to use, and we only need to do a few things in QGIS, export it, and we can use it in Power BI. I have prepared 4 examples, and I'll start with the first one, which is this one. So in this case, I have scenarios. If I share my data, I have sales territories with a sales revenue, and I've got scenarios. The scenarios identify different solutions in terms of how should the sales scenarios be presented, and what would be the revenue, and what would be the outcome if you have distances and everything else associated with the regions that we combine. So 4 scenarios. The first one is the current. These 2 are for the model, and the last one is balanced. In another piece of software, I created balanced territories where the algorithm in the software is looking to split up the territories in so much that in terms of distance and revenue, they are more or less the same. So if we head over to the map, we have a field parameter with the scenarios. We have the map, and we can click on the scenario, and subsequently the map will change. I will start to do it with the shape map. So although in preview, this is still one of the best maps that you can think of, because it's quick, and for things like this where you do not really need a geographic context, it's just great for this work. So my scenarios are displayed here. You can see in this table what happens if you change the scenarios. And for reference, I've got all the scenarios associated with my choices. So you can see and compare what's the difference in terms of percentage when you change the actual scenario to a balanced or an existing scenario. You can still choose the individual regions. So it's fully dynamic, and at the same time, you can play around with this and make a choice between the scenarios and subsequently how they divide geographically. I've done the same in the Azure map, which is really slow. And like the field map, it lacks certain areas because of translation issues. So although I have the correct names for the regions, they do not display properly in the Azure map. So apart from being slow, it's also not complete. We take the field map, similar issue, slower. This is the Azure map, and obviously it turns against me, and it shows this message. Sign in. This is a bug, and they're working on it. I'm in direct contact with Microsoft about this, having a meeting again next week, and they haven't yet been able to resolve this. In my other models, I've actually taken the precaution to add also the standard map so I can continue my presentation. This is the icon map, by far one of my favorite map visuals, which responds immediately. This is different for many of you, I guess. What I've done here is I've used a GeoJSON file. In the icon map, you can display points, you can display well-known text points or shapes, and you can also display GeoJSON files, which you can host on GitHub. So you can see here that I've got this shape hosted on GitHub. This is the map, and by displaying the raw URL of the page on the GitHub website, when you go back into Power BI, you can paste it in. You can also add several levels. So if you want, you can actually put several maps behind each other with different levels and drill down. So this is a great...
Can I ask a question, Paul? Just a quick one. So you can find... I am a complete novice to this. Yeah. So you can find the URLs anywhere for any country. So if I wanted the UK, I'd be able to find the GeoJSON files for that and then use it in...
No. what you need to do is to prepare your GeoJSON file, for instance, in QGIS. But you can get many of those files in the UK. I'm sure that you can. I've got postcode boundaries for the Netherlands and Belgium, for instance, where I do postcode maps. So they are readily available. And subsequently, you export them as a GeoJSON and you save them in your GitHub repository.
Okay.
So this is what you see here. Where are we? So this is actually my GitHub repository that I made and created for this. And as you can tell, I've got my GeoJSON here, which is from QGIS.
Yeah.
And this is the shape.
So I'd be able to search and find that elsewhere for anything I want. Okay.
Yeah. And then the key thing is that you store them on a server that is CORS enabled. And CORS stands for cross whatever. They've made a note somewhere about it, but it's got to do about the resharing possibilities. Otherwise, the map visual will not accept it, or Microsoft will not accept it. But this is working out fine. So as you can see, you can play around with your territories. You can play around with different maps, and I've got a few here. Basically, the shape map and the icon map produce the best result because they are fast and they allow us to do things and changes as we like. Best thing about the shape map is that you can actually put your parameter in the legend, and subsequently you can select the regions from the legend. And in the icon map, you have to play around with conditional formatting in order to get the colors right.
Okay, I've just got a quick question while you're on the icon map. I stopped you. You were explaining how you could layer the maps. Someone's Wojtek, apologies if I pronounced it wrong, has asked, can you explain more how you layered the maps?
Yeah, I will briefly explain it. In my fifth example, I've got an example of 2 GeoJSON maps. But what you can do is you can actually, if you go into your category, you can add categories here. Subsequently, you can drill down, and you can drill down in levels. So if I add here a second region, for instance, and I would add level number 2, and that would also be a URL somewhere on the web, then I can subsequently drill down into the maps. So I think you can go up to 5 or so. So it's great because it's like having a bookmark, but then with different maps and different presentations. That's
really clever, isn't it?
Absolutely.
Really clever. This is James Dale's, isn't it?
Yeah, this is James Dale's. It's absolutely amazing what he has done. And he's still developing, because I'm using his visual from the Icon Map website. You have one in the App Store. Yeah. But I'll take it from the Icon Map site, where you always have a few versions which are ahead of the ones in the store. They will have added functionality.
Okay, brilliant. Thank you.
Okay, so second topic is using well-known text in Icon Map. Let's first go to the data. This is a display of postcodes. I've overlaid the postcodes. I have an ID, and this is my well-known text. So for those who are not aware with well-known text, you have your longitude and latitude, and that is the correct sequence. So first longitude, then latitude, separated by a space between brackets, and you add a type in front of it. So it could be a point, but it could also be a polygon. You can also have multi-polygons. So the shape, name, the type, together with the long lat, will give you a well-known text string. And the icon map is the only map that can actually put this on the map. And the way to do that is basically go to Objects. And here you see Image or well-known text. And the visual is clever enough to actually make a distinction in one column, whether it is an image URL or well-known text, and will subsequently display it. So if I click here, you can see I've got my first well-known text, and that stems from this column in my data. So the way this is built up, I've got a Voronoi diagram. For those who haven't heard of this before, it is a Thyssen polygon or a Voronoi diagram. And basically, these are my supermarkets, and the segments are created inside QGIS around these points, and the distance between this point and this line and the distance between this point and this line is the same. In other words, if I add my customers to the map, all these customers are close to this supermarket as opposed to customers in this segment where they should probably visit this supermarket and so forth. It's not called icon maps just like that. So you can also display this with icons. Got supermarket icons. I've got customer icons. This is a different way of displaying data. James Dales has an example where he's got aeroplanes flying across the map.
I've seen that one.
Yeah, that's great. And this one is actually working with images. And I've got the images hosted on a free website, ImageBB. And all you need to do is basically just refer to those images, and you can subsequently input them in the well-known text field. And the icons, and if I go to icons, this is the switch that creates the display of the icons on the map. So a switch true with the selected value being either a supermarket or a customer, and subsequently this is the URL, the image URL that is used in the map, but also here in the visual just for display. You can actually on record level add URLs. So if you, for instance, in this case, I could have taken the logos of the individual supermarkets and subsequently have a different logo for each of the supermarkets in my data. And for the rest, you can just play around with it and actually just select what you want. So in terms of the presentation, just like points or with icons, it's definitely completely different from what you can currently do in the Azure Map Visual.
I've got a couple of questions.
Yeah.
So Adrian says, Voronoi maps partition a surface, though aren't Venn diagrams better in depicting the overlapping? There are customers who, depending on the situation, can buy goods from more than one stores.
Yeah, I mean, this is all you do in this map in particular is just identifying closest customers to supermarkets. If you want to carry on and do a more detailed study about people visiting supermarkets, you can do a gravity analysis, which I've got in an example as well.
Okay, perfect.
Yeah, I use this, for instance, recently I did a map on all the train stations in the Netherlands and how close were they to postcodes. So I started off with creating a Voronoi diagram for over 400 train stations. And immediately you can see the distribution of the stations versus the size of the segments and the postcodes. So it gives you a clear picture initially of where you have to put your attention to.
Okay, perfect. Thank you. I'll let you carry on.
Yeah.
I think Anthony's answering Rahul, so we can carry on.
Okay, good. This is a third example as related to logistics. What you see is a visualization for a hub and spoke distribution network. And I've got my delivery addresses and I've got the delivery depot. The colors of the bubbles are representing this particular. So in this case, depot I has the brown bubbles and J has these bluer bubbles. And normally these distribution networks have allocated postcode areas and they have a central hub. All the depots collect their products for the customers of the other depots from a central point and deliver it within their particular defined region. The nice thing about this is that you can actually start comparing different regions. And what you can see is you can make a selection between the two-digit postcode or just the postcode and see how many shipments you've got in those two areas, the number of packages, the weight, etc. So it gives you a better view when you are doing a study on these kind of networks what you can expect if you start making changes, because most of the time I'm called in to look at it and restructure the network. So the first thing you do is create an as-is situation, and from there you start looking at the overall situation. So this is a clear picture of such a distribution network.
Fascinating, absolutely fascinating.
Yeah, I use them as a first visualization. So the first thing I do when people throw a lot of data at me is basically just map them and do a first visualization and display the extent of the distribution area. And I can analyze the associated data at the same time. And this works much better than do a simple pivot table or a matrix or whatever. And it will help me to answer questions like, where are the customers located? Is there a demand pattern? What are the service level agreements? Because I can definitely change the color with conditional formatting of these points to identify on-time deliveries, late deliveries, delivery patterns that are different from other locations. I can also identify if I should do something about the size of the network. If you look here in the north, you can see that there's a huge area, even for the Netherlands, for a final mile distribution network. So you should do something about it. So you first start to look at the as-is situation. And also there is a line haul aspect. If you do nightly line hauls from a central point, the distance from, say, a central point here to this location or to this location is completely different. So you have a line haul infrastructure that you need to look at as well. So this is a basic and simple presentation of such a network. So the next step is to identify center of gravities for those locations. So as a simple representation for that, this is a map showing the customers in blue, the existing depots, and the center of gravity. They are all in one map, and it's all done with conditional formatting and stacking all the data in one table. So if we go to the table, I get this right the first time, hooray. Where are we? So we have the depots, the center of gravities, and we have all the other customers inside here and the names. So by stacking them up and with conditional formatting, I'm able to show them on the map as if they were multiple layers, which, as we know, is not possible normally in Power BI. Unfortunately, it would be great if you could actually drag several layers onto the map and display them in terms of I've got this point and this associated with all the other points. That's not yet possible. So this is a way of doing it. So the center of gravity is calculated in a calculation like this. And then I create a single row, and the single row is with a union connected with the other points in the data. And eventually I end up with having the center of gravities for each individual depot and its customers inside one big table. So the data table is a combination of the union of the forward stock locations and the data plus the center of gravity. So if I click a depot, it's falling down on me. I'm sorry. Hang on, I've got a backup. Okay, so I don't know if other people have this as well, but this is really annoying. It happens all the time. Yeah. But fortunately, I made a map backup. So this is the same map, but now in the map visual. It's slightly different in terms of the size of the bubbles, which is one of the reasons why the Azure map is collapsing, is that it cannot take over the conditional formatting in measures, and subsequently it just falls down. But I can actually select a depot here, and if I select the blank are actually the center of gravities. You can see that I've got this point with its center of gravity, and for reference, I have the center of gravities in the other areas as well, which is giving you a clue about distances and the time associated with getting to those points. Because ideally, obviously, you would like to have the customers the depots in the same place as the center of gravity. So this is looking all right. but this one is much further away from the center of gravity of the area associated with that particular depot. And the
Can I
same
ask a
applies
really,
here.
really basic question? Center of gravity is the center of where most of the people live.
Yeah, well, you can look at it from different points. A center of gravity in this situation is weighted. So what I have is the weight of the number of shipments, which is the most important cost driver in transportation.
Yeah.
And what you do is you multiply the number of shipments with your latitude and longitude points. And then if you do a division at the end of that calculation, you get the center of gravity. So you get 2 points, the center of gravity latitude shown here and the center of gravity longitude shown here. So this is the result of the formulas that I showed you here.
Yeah.
So you calculate this sum, do a sum x over the table for this particular depot, and I've done that for each and every individual depot.
It takes me a while to read DAX and comprehend it. My brain goes slow when it's DAX.
Okay, well, same goes for me really, because I've done this many times, of course, but this is something which you would normally never do in Power BI, but it was just tempting to try and do it in Power BI, because I would normally do this in QGIS. And I've got an example here where you can actually see a similar calculation. So if you look at this, then this is merely a display. Bear in mind, once you've got the center of gravity, it's more or less static. If there's not a lot changing in terms of the delivery frequency within this particular area, the center of gravity will sort of stay static. So once you've got this calculated, for instance, in QGIS, you can export it as a GeoJSON or well-known text and display it in Power BI. What I intend to do, as I said before, is bridge the gap between actual GIS software and Power BI and display in Power BI maps what you have constructed in QGIS software.
Okay, brilliant. Yep. Thank you.
So, okay, sorry. This is a nice one. I've got the icon map. I've got 2 GeoJSON files. I already demonstrated the use of GitHub to put your URLs on for the GeoJSON files. I've got a test page. So basically, I'm just testing my URLs without anything else. And I've got it for the districts. And I've got 1 GeoJSON file for the neighborhoods. These were prepared inside QGIS. Now, I've got a data set with 126,000 points, which even in icon map takes a little bit of time to display. What you are looking at is a city in the Netherlands, and this is part of a challenge where for a charity we prepared Power BI maps in order to help them with their work. They are volunteers and they are collecting litter from the streets, and they take a picture of everything they find. And that could be around McDonald's or restaurants or bus stops. So they've got the latitude and longitude of the find, but also identify if it is a can or a bag or whatever. And we were helping these people with and building a number of dashboards to see whether we could help them out in terms of visualizing what they are doing and getting more exposure for the good work that they are doing. And subsequently, I built this map. And as you can see, I've got far too many points for even the icon map to display. So I would like to aggregate the data. And the best way to aggregate it is to put it inside containers like districts and neighborhoods. So this map is built from 2 GeoJSON files. You can see here the 2 levels, level 1 and level 2. And I can also display the points. I'll first do the drill down. So I can actually drill down here, and I can drill down again to the points. So obviously much better in terms of the way we can look at the individual points. You can see that people are actually walking, so these points are very close together. And you can go up again. You can go through the individual parts of it. And as you can see, I've got 126,000 records, and they are displayed inside this map. And I can go all the way down to points. I have to be patient here. Right. So inside the map, I've got my district code, I've got my neighborhood code, and I've got a combined latitude and longitude. In this map, you cannot simply input the longitude and the latitude. It will not allow it. It will go absolutely blank. So in order to display both the GeoJSON files and a point layer, you have to do a little bit of work on your measures. So longitude and latitude in the icon map visual will accept a measure instead of a static latitude or longitude value. So you first create a level where you use an in-scope to identify whether it's a neighborhood or a district or a long lot, which are the points. And then you have another measure which calculates the latitude and the measure that calculates the longitude associated with the level. So if the level is this, you take the point longitude, the same for the latitude. And as a result, I can display points and GeoJSON files with shapes in the same map. How cool is that? Any questions here?
I think, well, I'm speaking for myself. I'm a bit blown away, really. We've got a Rahul saying extremely cool. I've only had one experience of shape files in GeoJSON, and it was probably about 5 years ago, and it was just like, oh, it's really quite complex.
Yeah, it looks complex in the beginning, but the explanation you get on the website from James and just doing it is very, very helpful in terms of achieving what you see here. Because all in all, what you're talking about is building a shapefile, importing it after export in terms of it being a well-known text file with the longitude and latitude in a string, or with a GeoJSON or a TopoJSON file, and subsequently inside the custom visual or even the Azure Map visual, you can process those files and they will display.
Yeah. So, and you can quite often find shape files, can't you, similar to the GeoJSON that have already been created for well-known areas.
Yeah. I mean, for instance, speaking for the Netherlands, we have an institute where you can actually get the shapes for the districts, the neighborhoods, the postcodes. So, being in transportation, I do many zip code files, and I do a lot of mapping with them. And it's actually quite easy. And the key thing is that if you have a map that is able to process the number of records that you have, if even by aggregation in boundaries, then you're good to go.
I remember, I think the work I did was it was councils in the UK, and they had different boundaries compared to different layers. So the layers didn't fit inside each layer as you went down or up a layer. Then they'd spread over each other. So we've got a question from Mikhail. Is it possible to edit the key, e.g. postal code format in the GeoJSON file using QGIS to link it to Power BI?
Yes, so you can actually edit the names. It's absolutely imperative that you've got a similar name in your data as in the map. So in QGIS, you can actually edit the names to make sure that they are comparable or the same as in your data set. If you do not have the same names, you will have a problem. And if, for instance, if you have German names and you have the umlauts, then sometimes you have to reprocess your data or the map to make sure that the letter with the umlaut is actually accepted, the character with the umlaut is accepted. So you either change it with or without in order to make sure it's in a comparison.
Okay, brilliant. Thank you.
Okay. Another example. What we've got here is a Huff gravity analysis. You can do this type of analysis in many ways. In this case, I've taken it for, again, supermarkets and customers. And what you are seeing here is the probability of customers visiting a supermarket in a particular location. So at this moment in time, I've got the 3071 selected. This small map shows you the other supermarkets. I've got a map behind here in the Azure map, but for safety's sake, I've done it in the standard map. So you can see this is the bigger shape. This is slightly less big, but still bigger than the other ones. So this already shows the emphasis of customers for visiting a particular supermarket. And the calculation beneath this is actually that the gravity analysis assumes that the surface in square meters of a store divided by the distance squared or travel time will give you an attractiveness factor. And that factor is displayed in this map. So if I go on to this supermarket, you can see it's down here. If I go to the one here to the left, the darker the area, the greater the probability that people living here will visit a supermarket which is based here. And I've displayed it here separately, otherwise it would be covered by the map. But the supermarket is somewhere hidden beneath here. Now, this is quite interesting because you can also do this with other kinds of analysis, and you can also add factors into the equation. Imagine that this is okay for doing your daily or weekly shopping for in supermarkets, but if you buy furniture, you may be willing to travel further because you're not buying furniture every week, I hope. So you can then add a decay factor to make sure that the distance becomes less important and that the size of the supermarket or the store or the area where it's based is more attractive. So the attractiveness factor is calculated in this presentation on square meters and distance, but you can add other factors as well. In this case, I've used the Mapbox visual, and the shapes are in a choropleth map. This is called a choropleth map. Mm-hmm. And similarly to what you can do in the icon map, you can have levels, so you can use different levels and several levels displayed in the same map. You make a selection for a custom tile set, and then you've got a vector tile URL. So this is a URL, and this is all hosted on Mapbox. So the Mapbox website associated with the Mapbox visual will allow you to create maps like this and subsequently display.
Who did you, I think Alice in Australia, she does quite a lot of tutorials on...
Alice Drummond, yeah, she's great.
Yes.
Yeah, absolutely. She's great. Mm. Yeah. So I think, there are a few people who, like Alice, are doing a lot with maps. Alice is doing a lot in water management. So she's doing a lot with...
I've got her booked in for the summer.
Oh, really? So, good.
Yeah,
yeah. I was actually chatting with her earlier today.
Oh, wow. Yeah. She's awesome.
Yeah, she's nice. So as you can see, we've got color grades, and the color grades correspond with the probability of that selected supermarket. And it really makes a nice display, and you can see that you can use it for other options as well, of course. Okay, that wasn't too bad for time. Then I'll move on to QGIS and show you something here. For those who are not familiar with QGIS, this is free software. You can download it, install it. Then you have a number of plugins, and the plugins are the tools that you use to process the maps and to do all sorts of things in terms of distance calculations, even geocoding, you name it, and it's there. And those plugins, most of the time, they are written in Python. So you have a Python script running in the background, which is actually carrying out a task. So consider them all as little software programs that do a job for you. The good thing about it is that the Python scripts are inside and are stored inside the install of QGIS. So if you, like me, have a Python install separately on your computer that you also use in Power BI, you will not have a conflict using the Python library for Power BI with the Python library used in QGIS.
Yeah. So, and can you obviously go in and change the Python scripts in QGIS to have it how you want it, so you can amend and alter and edit?
Oh yes, there's a lot going on here. You can actually go into the script part of it right here, and you can actually add your own scripts and do your processing of the maps. So what are we looking here? This is a simple brownfield analysis, and a brownfield analysis basically is used to restructure a supply chain when you have a growing or shrinking distribution network, as I displayed in the other example, this one. If you want to consider that that this area is big and you want to have a different or a separate or a second depot here, and would that conflict with other depots, then you do a brownfield analysis. So the brownfield analysis here is you start with an as-is situation. So these are my current depots. This is the central hub. So this is a typical hub and spoke network. I've got my as-is situation. So these are all the delivery points. And in order to make it clearer, I can also add the current allocation. So again, each green point is a depot, and the colored bubbles represent the delivery area, the postcodes associated with that particular delivery depot. So if I add the weighted center of those 10 depots, you can identify whether the depot is nearer or further away from the ideal situation. The ideal situation being that given the number of shipments and the distance, it would be better if your depot would be based here instead of where it is over here. So particularly here in the north, you can see that this depot is far away from the center of gravity. Again, talking about final mile delivery and distribution. But otherwise, are sort of spot on. So if you want to restructure a network like this, you immediately focus on those locations where you can see at first sight that you need to do something about it. So what you run then is what they call a k-means clustering. That is a particular algorithm that will redistribute the points and then start building a new network, if you like. So if you do that, I have to be careful, there's a lot going on. Hang on.
It's brilliant, though. It's just so clear the way it's visualized to see the information.
Yeah, I've got to turn a few off. So as you can see now I've got 11 instead of 10 areas. There's a complete difference in terms of the distribution. These are the suggested points. If I add the existing points again, you can see that there is a sort of reshuffle of certain areas. You can see where the points are. And you can see that here in the north, we've got a second point to make sure that we have a better split up of that big area.
So there's a question, how often does the data refresh? I guess it's quite static, the data, apart from the visits, maybe.
Yeah, my experience is that if I've done it for a logistics services provider and the next one comes with a similar question, probably up to 95% of the addresses are similar, because what you are looking at is postcodes with industries who are getting deliveries and with customers getting deliveries. That doesn't really change over time. So even over years, you can say that eventually this is sort of static in terms of the representation of the dots on the map. And probably the amount of shipments or the weights will differ, but not so much geographically.
There's another question from David. Hi, David. Can this sort of analysis translate to seaports and terminal locations? And would it differ?
Of course,
how
you
would
can
it
do
differ?
this. Well, you can actually do center of gravity calculations in many ways. In this case, I've taken straight line distance, but you can also do it in other software and also in QGIS, but I've never tried it in QGIS with actual distance. So if you have bigger supply chain projects where you want to look at things in terms of offshore and onshore production and what would be the best place to produce something and then subsequently distribute, for instance, in Europe, then you can do similar studies like this.
And Fernando's asked, how much time did it take you to build this model?
It's about an hour.
I think that could be because of your skill level, Paul.
Yeah, well, I suppose, once you get used to it. But I mean, you have to look at it like this. You import your data.
Yeah.
Then subsequently you run the plugins. The plugins will do the work for you. And then you start iterating to find the solution that suits best. So what you need is your domain knowledge and the way you can deal with things in QGIS. And again, eventually my end result is that I want to take it from here. Like you said, it's more or less static, export it and display it in Power BI. And then my customer can play around with it dynamically. And I mean, if you look at, for instance, the suggested allocation, if I right click and I go to the attribute table, I see all the points and the associated clusters. I close this and I then go again to export, save features as. I can save it as a shapefile, as a comma separate file. So if I save it as a comma separated value, I can create well-known text. But I can also export it as a geo package or an S3 shapefile. So this is where it all happens. Eventually, you export it, GeoJSON, and then you've got the file, and you can subsequently use that file either as well-known text in the icon map visual or the GeoJSON map, for instance, on GitHub, and start displaying it.
Brilliant. So you do the initial analysis and looking at it in QGIS, then you can export it as a GeoJSON or a well-known
text string.
Well-known text string, and then pull it into Power BI. And then once you've got it in Power BI, you can add in other data into your model and use it with this.
Yeah. So, I mean, this map, the shape map, the GeoJSON map, was created in QGIS, exported, stored in GitHub, and now used in the icon map visual.
Can I see your
And the nice thing about the GeoJSON is that you at least have control about where your data are stored, in this case in my GitHub repository, versus having it on the server of someone else.
Yeah, so someone asked a question about that earlier. Who was it? Hang on, I'm just going back up. Yeah, security protocols.
Rahul asked it.
Yeah, Rahul asked just to say, I think you answered it, Anthony, so that's why I didn't bring it up. But he was asking about the confidence. That was it. Is Icon Map reliable to share sensitive data with? What if your data is confidential? Does Icon Map store it on their servers?
No, Icon Map is not storing it on their servers. And if you use well-known text, your data is actually inside your model.
So so that's what Anthony said as well. If you use well-known text, then it's all held within PBI.
Yeah, and if you use a GeoJSON, which is stored on your own GitHub repository or your business's repository, it is safe from that extent. And, how much safer can you get it, I guess?
Yeah.
Even Microsoft is storing things, and you and I don't know whether that is completely safe or not.
Yeah, you hope so.
You hope so, yeah.
Gosh.
Okay, well, I think well in time.
Yes.
A number of things associated with mapping in transportation and logistics. And this is a combination of what I do in GIS software and Power BI.
Yeah. So Wojtek said he really likes the use of QGIS and icon map together, but really didn't think of analysing the data in QGIS. Perhaps haven't got such project need yet. No, I hadn't thought either. But I'm guessing from what you've said, Paul, that for you, your visualization mapping tool of choice is icon map.
Yeah, by far. If you look at the ability to display shapes and points in the same map, it's absolutely ideal. And even because even if you have that many records like I've got here, you can still display it and it's still readable.
Yeah. Yeah, I've seen James's presentation. It's just absolutely mind-blowing what the one with the aeroplane and storms coming in and all sorts.
Yeah.
So this is, this is fascinating, seeing how you use it. And Fernandez said, now you can store the data in the lakehouse in Fabric. Yes.
Yeah.
Yes, you can do, Fernando. Question, what would some of the drawbacks of Mapbox be for you, Paul? This is Rahul, it seemed like a fine tool to me once when he used it.
Well, I think it's great still, but it lacks certain capabilities in terms of, let me show you.
This is really fascinating to see you know how you would use this in in your day work, in your Christian said, were the 3D shelves explained earlier in the meetup? What 3D shelves?
3D?
Don't know, you've lost me, Christian. Drawbacks of Mapbox.
Well, drawbacks of Mapbox. I like the way I can process the maps in Mapbox Studio. So to me, that's a great advantage. The downside is that my information, my maps are on the Mapbox website, as opposed to using a GeoJSON in the icon map visual, where I can put it on my own repository. But in general, the map is great. It's functioning fast. It's responding really fast. It renders completely different from the Azure visual, because I initially used the Azure ArcGIS map visual to do this, but it took ages to actually process a change between one supermarket to another. And this one is much clearer.
Yeah.
So those are the advantages. And I do not really think in terms of drawbacks, because then I try to find a workaround or use another map visual. So this is how I started. Consider which map visual you want to use for which purpose. Yeah.
Okay. Christian's just being told off because it's his fault for turning up late to the meeting. No mercy, yes. Particularly as he dropped in, that's because he was preparing for his skiing holiday. So
right.
none of us have any sympathy for him whatsoever. And Fernandez says, how do you make tests to confirm the result of the probabilities calculated?
Say that again, please.
How do you make tests to confirm the result of the probabilities calculated?
Well, like anything I do, and I guess most of us, you simply recalculate a number of things. Then you use common sense in terms of, can this be right? And then if you display it, you can soon enough see whether the assumption was right or not, or that you need to tweak your data.
Yeah.
Okay. Yeah. I mean, I've tested this, for instance, in another model where I've got a dynamic allocation. What I did was I've got the factor of the square meter surface of the supermarkets, and I can use a parameter to change the size of the surface. So subsequently, what you should expect and what happens is that if I will change the size of this supermarket in square meters, as opposed to reducing this one, you can see that the attractiveness is moving from this point to this point. So that in a way is also a check.
Okay. Okay. Cool. Fernando says, so you get updated data to know if the supermarket received that many visitors. So you can check to see, I guess you're validating all the time to make sure that the assumptions you make are correct.
Yeah, well, no, I haven't done that in this case. This is a display and it's just a demonstration, if you like, but the Huff gravity analysis is used worldwide.
Yeah, yeah. Are you happy to share some of some of the Power PBIXs, or do you keep them for demonstration, or?
Yeah, well, I keep these for demonstration, and they are part of a new training course that I'm developing for an institute in the Netherlands, so I keep them to myself. But if people have questions, they can always turn on to me through LinkedIn, for instance, or through you. And if I can help them, I will certainly will.
Yeah, and Paul has, like myself, he's got several courses on enterprise DNA, which are brilliant, that you can then use. So Rahul, you can sit and learn from Paul, and the enterprise DNA site is just fabulous, isn't it? It's got so many excellent courses, and Anthony's popped in enterprise. Deliver, which is run by Alice, and she has just got some absolutely superb tutorials on how to just how to do anything with images within Power BI, including, it was through her I learned about the image BB for storing images so that you can actually pull them in.
Yeah, Alice is absolutely brilliant. She's got a blog and a website. And you can find many examples of using maps in her field of business, if you like, in her line.
And if you go back to the historic ones, then she starts off at the beginning, which is where I joined her. Yeah.
It's very professional now, I can tell you.
Oh, she's brilliant. She's absolutely brilliant. So she's coming in the summer, I think, after baby number 2. She's going to come and join us and give us some work. Someone said, can you link the enterprise DNA with those courses? I haven't got that. Have you got them to hand, Paul? You can, if you go into enterprise DNA, you'll be able to find them and search under Paul's name. Yes, I know, Christian. He's saying Enterprise DNA is the main official sponsor of his meetup group.
Yeah,
I do this too frequently, so you get more. Any more questions for Paul? No. No. Do you know Voitech, do you know Enterprise DNA, the URL? If you have a look, then you'll be able to search for Paul's courses. Yeah, cool. Thank you, Paul. I'm just like, woo. I would have to watch that again, but I think the takeout for me is just seeing the capabilities of what you can do, which and learning new language all the time. It's fascinating, but also I think for me it would be learn more about Icon Map for sure, because the capabilities that you showed was fabulous. And Darren says, very informative, thank you for the time you put into the presentation.
That's my pleasure. Thank you very much, and I hope that more people are getting interested in using maps in this way instead of just a few bubbles on the map and being happy with it.
Yes, definitely. Definitely, and definitely, because and it just answers so many questions, doesn't it, and allows you to plan. So next week we have got Laura Graham Brown. So she is coming in to talk about Power Automate and Power Apps and Power BI and how we can all use them together. I've asked for some more Power Apps stuff because Laura helped me. We were building a Power App and all run by a Power BI flow, and it's just being able to use the Power Platform when most people have got the the need to be able to do that. So fabulous session next week planned. And again, Paul, that was brilliant. So lots and lots of thank you and claps. And I think you've whetted our appetite and sort of also blown me away again. But yeah, thank you. And good luck, Fernando, for your DP 600. So he's studying